We're doing this demo today to show the difference in thickness of plated and unplated parts. Most of the demonstration is done using the touch probe, so because video will only measure near the edges where we won't see the real change. We'll run the machine measuring the parts first. This is about a 6 or 7 minute demonstration, and then we'll go back and let you see the results and what it looks like in the model window. We start off measuring the two round parts. We're going to measure the diameters of both parts, both ID and OD, and after we measure the diameters of both parts, we'll subtract the difference in size to get the physical thickness. It's done measuring those parts now, and as it goes to the next set of parts, the plastic parts, it'll set up the datum with video before it starts. But the diameter difference between plated and unplated was about 5,006 80 millionths. 5,006 80 millionths was the difference. We set the datum on the part so that we can find it, and then we'll go back and measure with the touch probe again. And again, the reason we're using the touch probe rather than video will only measure at the edge of the parts. And as it's plated and gets toward the end, if the thickness isn't the same, because it is running toward the end, then we would give an incorrect data. By using the touch probe, we can ensure that you'll get correct results from the system. The machine we have here today has the vision as the primary sensor, certainly. We also have the touch probe that we're using now and the laser option. Now, the laser is not required on these parts, but it certainly is available on machines for high accuracy Z-axis measurements or for Z-axis profiling. And again, it's just going and measuring the various widths of the windows so that we can compare the plated to the unplated. We've just set the parts on very simple fixturing here. We're using a couple of dovetails we had laying around just to elevate them, and we're using a double back tape to hold them. In actual operation, you'd probably want to hold the parts on some more elaborate fixturing than we're using. And the fixturing is normally made from, we use Lexan as a base. And you could just cut out pads in Lexan and then just use a simple spring-loaded bar to physically hold the part so it didn't move. And we're setting the datum on the part with video to make sure we know where it is. And now we'll go back and pick up the probe again. And the machine today that we're using is a 12 by 12 inch travel. It has 6 inches of travel in the Z-axis. And for these parts, certainly a 8 by 6 or 12 by 6 machine would certainly do it. It would just mean that you could only put one part or two on the table at a time rather than using all the parts. Along with the video that we're creating here, we'll send the inspection report printed out so that you can see the physical dimensions that we measured on each one of the parts. They will all come in one tabular form. We wrote this all as one program for the demonstration, rather than having multiple programs that we'd have to start and stop the machine. That's the Z-axis using the focus target, and we're measuring 2 circles to establish the datum and the axis alignment. The system is very straightforward to program. For what we did here, it took us about an hour and 15 minutes to get everything set up and ready and programmed for the demonstration. Basically a very short time frame. We're measuring the width of the parts. When we go to the plated parts, besides measuring the physical width, we'll also measure the dimples on the plated parts so that we can see how far they've gone in from the surface. And we're setting the datums on the last part. Again, one thing that the machine gives us the ability to do is measure the exact points on each part, so we're seeing exactly the difference from one part to another. We don't have to worry that we've measured one point on one part, one point on another part, and not getting an accurate representation of what the plating really is. Certainly the inspections can be in-depth as we like. To measure a line or to get a physical thickness, we can measure 2 points or even a single point on each side to get it. Measuring multiple points, though, gives us a much better average. We can measure both an X, Y, and the Z to get the physical depths and heights also. Measuring the dimples now. And that concludes this part of the inspection. After the inspection is accomplished and during the programming, we create a graphical representation of the parts we measure. We started off measuring the two pieces of carbon, one plated and one not. And even in the visual representation, you can see that the plating is a little bit bigger on the right one than the left. If we go back and look at the plastic parts quickly, and again, what I'm doing is just zooming and panning in the model. Excuse me. Show you the features we measured. This was the non-plated part, and then the plated part on this side, and then we went up and measured the two castings. And again, we could take as many points as you physically wanted. We just limited enough to show the capability of the system rather than a total inspection, and the plated side on this side. Okay, we just finished showing you the graphic window, which is the top right section of the display. The window underneath it is our program steps. On the left side bottom we have our print listing that shows all the results in the inspection. The window that we see here on the left is either showing the touch probe connected to the machine showing probing in progress, and the live video would also show up in that window. The system as it stands can be shown either on a dual or single monitor. We're showing a single monitor mode now, but on a dual monitor mode, this window where we would show our graphics would be approximately 2/3 the size of the screen you're looking at. And then the second window would have your graphics and the programming steps and the print listing on it. So we move all that to the right monitor and you just see the video or the probing in progress on the left. This concludes our demonstration today on the plated parts, just showing the difference in thickness from plating before and after. You can contact us at RAM if you have any questions, or certainly the distributor. Thank you again.